In this program, we're going to look at using the data that we generated in the previous R video and use it. We'll see how to load it into Excel and load it into SPSS. In Windows, loading Excel is pretty easy, and I'm assuming it's similar to that in the Mac. But here is our file that we generated, May 18th. I'm going to just double click on that. And it starts, that CSV is seen as an Excel file, and it loads it up. And there is our file. I want to center everything. And we see we have two columns. In the first column we have the sample, sample 1, sample 2, sample 1, sample 2, sample 3, sample 4, which we don't care about, 3 and 4. And then an X value, and it has a horrible number of decimal points that we don't really need. In Excel, we can copy down, highlight this line, and then just come over here in this section and reduce the number of decimal points if we'd like. So maybe down to 3. And then we can save it. But when we save it, we will want to save it someplace, but we want to be sure. Oh, well, it saved it again as a CSV. I want to save it as a, File, Save As, and the random normal sample. We don't want to save it as a CSV file. We want to save it as an Excel workbook, because that way when you add formulas and stuff, they stick around. All right, but we don't want to do Excel right now. We are much more interested in doing SPSS. So let's open SPSS. And when you open SPSS, this is what you get, this screen. Let's get rid of R in the background. Okay, so we have I don't personally ever use this particular screen, but sometimes it's helpful to go over the last one, but we're just going to close it. And what we have here is a data view. Well, actually, this is a variable view, where it is going to tell us our variable names, and then this is going to be the data. So we're going to just file, and we're going to import data. If we had an SPSS save file, we would just open it. But we don't. We have a CSV file, and so we can import the data. We can import it in a number of different formats: Excel, CSV, text, SAS, Stata, just a number of different things. So we want to do CSV. So let's do that. Now it says, where is it? Now I happen to luck out, and this came up in Stats Demos, which is where my folder is located. But remember, you took note in your R program where the working demo was and where that file was going to be saved. So we see here that in this particular subdirectory, I have my file located. Finding your file is one of the tricky parts, and so you want to be sure and make note of that working directory when you run the R program so you can come up with it. So here it is, and I'm just going to open it. And now it's working. It's found a thing. It's read this. It's got the titles up here and then the samples. In this case, my first line contains variable names, the sample name and the X. And if I wanted to do it, I could remove leading spaces from string variables, just a number of things. But really, in this one, I don't have to do anything. It just comes up and it's reading that correctly. So I'm going to say OK. And this is the output file. And the output file has a little outline over here. It's output and it's log. This will be more useful once we do more things. So the data, it had two variables and 80 cases, and it gave the format. The format for the numbers was pretty bad. It's 19 spaces with 16 decimal points. We're going to look at that now. So in order to get back to our data, we have to, at some point it's going to show you if I'm getting these two little file icons up by hovering over my SPSS thing. There should be some place on your computer where it has the program and you can choose between the output file or the data file. And I'm going to pick the data file. Notice that there is a bar here that has your variable names, or a row here, and then the actual data starts on row 1. In Excel, row 1 is the variable name, so got to be careful about that. Sometimes that'll be confusing because subject 1 will actually start in row 2. So if you use the row numbers, you get messed up. Now, I don't particularly care for this many decimal points. So I'm right now in data view. I'm going to go to variable view. Remember, you have a data view, a variable view, and then you can go to a different file that has an output. I'm going to keep this whole screen, both the data and the variable view, a little minimized. So not minimized, but smaller, so I can easily click over there. And I might even shrink this one so I can see it when here we go. There, now I can see both, and I can click into either one. If you have two monitors, you know this isn't as big an issue, but with a single monitor, you want to be able to see both because it's going to flip back and forth between these two. Now, here notice our width for the sample name. It's a string, 7 characters long, and SPSS, when it converted, found the most efficient one and didn't find any strings in the name longer than 7. The X, however, is numeric, and it gave room for a lot of decimal places. So if you click on this, you can use the little arrows to get down to fewer. You have to reduce this before you can reduce the width, because it'll get upset with you when you try to give it fewer a width that's smaller than the decimal places. There's other things you can do, for example, values. Well, we can add one. The value is sample 1. And we could label that sample 1 space. Not very useful here, but when you're entering data, and let's say you have gender female 1, male 2, you can have here, and then in the values, know that you've made females 1 and males 2, or however you set it up. And that way, when you enter your data, you just put in a 1 and a 2. You don't put in some other. And some of the SPSS statistics program don't like letters, so you would do 1 and 2 rather than F and M. Okay, let's go to our data view. We see this. SPSS tends to line string variables to the left, and numeric variables are right adjustment. So you can do something about that, but it's really not worth it. Okay, one of the things we looked at were histograms. Now, when we go to analyze data in descriptives, there's two basic programs that'll give us the descriptors that we have looked at, mean, median, mode. Actually, there's only one that gives you the median, that's the frequencies. The descriptives give you mean, standard deviation, skewness, kurtosis. Frequencies, you can get all of that too. So let's do frequencies. And then the variable we were going to want to look at is x. And the statistics, we want mean, median, mode. We don't have to do the sum. You can also do quartiles. We want to do a standard deviation. We can get the range, which is the difference between the min and the maximum. And we can get skewness and kurtosis values. Now remember that kurtosis, the original kurtosis formula gives you 3 as the center point. SPSS subtracts 3 from the computed kurtosis so that 0 is the same as a normal distribution. So if we do that, one thing on continuous variables, I don't really like to display the frequency data because it tends to just give you a super long output. If we were doing count data like gender, and we had males, females, non-binary people, we would probably, those are counts. It's not continuous. Those are all categories. And we would want to see how many of everybody we have. But this one, we're just going to do that, and instead of the counts, we're going to do charts. And specifically, we want to do a histogram. And one of the things you can do is show the normal curve on the histogram. And we'll continue. And there's some other things you can look at, but this will be enough. Now, notice we had 4 groups, but we just get one histogram. So what we want to do is we want to get this bar graph. And we asked for a normal distribution. You can see it's not very normal. And that's because those means were so different with groups 3 and 4, which are still in there. So let's go up and let's do this same thing 4 times, but we're going to only have to run it one more time in order to get 4, because we're going to go into data and we're going to split our file, and we're going to, and so let's look at that again. We want to split file. We don't want to split into files. Splitting into files gives you 4 little files there'd be a file for sample 1, a different file for 2 and 3. We just want to split the file, and we want to do the same analysis on all 4 things. So our groups are based on that. And then, okay. And now you don't really see anything different in the output. It looks the same. Now if these were random, it would put all sample 1s and then sample 2s, then sample 3s, and so forth. All right, now let's go to descriptives and frequencies again. And it's very kind to us. It remembers what we asked for before. And so the charts are still there. The statistics are still there. Everything is like we did before, only now we're going to run it again with different groups. So we just say OK. And now we get on our output. And I'd like to point out again this little outline over here. We can look at our last run by clicking up here, and that's the single graph, which we can click there to see it. Or we can click down here and see the group that is down at the bottom, 3, 4, and so forth. And so what we have here, now our individual graphs look a lot more normal. Now, are these normal? Well, they are by definition because we randomly sampled them from an underlying normal distribution. So the fact that they deviate a little bit from that is kind of irrelevant, but it tends to be a little confusing. One of the things we can do when we go to descriptives and frequencies descriptive, analyze, descriptive. Once we're in descriptives, we can do frequencies or descriptives, but we can do something called a QQ plot and put that over there. And we're going to look to see if it's normal. The QQ plot gives you a little illustration, and the idea is it's normal if these dots follow a relatively straight line. So it plots the observed value and the expected normal value, and this is a residual plot. But you can tell it's kind of a subjective thing, but these are pretty much along a straight line. If it was skewed, it would come off like that. Look terrible. All right, so that's that's finding our values. Let's go back up here to our statistics. And we see our skewness is minus 0.073, minus 0.22. If we look at this first one, our skewness is a little higher. It looks a little more skewed. And kurtosis is minus, so it's kind of saying it's flatter than we might expect. If we look at kurtosis down here, we get close to 0. Oh, that one's pretty flat, a little off. These are random samples, so they're all different, based on exactly the same underlying model. Keep this in mind when you're simulating your data. You'll want to run it a couple of times to see how consistent your data can be. The other way you can make your data consistent is to increase your sample size. So 20 is not a very large sample for a group to get consistent data. Once you get over 30, if you're getting from a normal distribution, it's pretty good. If your data is less normal, you want to run a lot more subjects per group. But you only have so much time, so you got to weigh the costs and benefits of each. So those are histograms. Let's look at a few more things. Let's take a look at graphs. Now, before we do that, we like looking at our data in a single graph. So we want to get rid of the split file, but sometimes we may want to compare the groups separately again, but for now we're going to analyze all cases and do not create groups. Now you don't have to do this if you haven't split it first. And in fact, you could just reset it and get rid of it and not bother with this one. But we're going to look at all groups at once. We're going to look at graphs. And a nice graph to look at is a box plot. And we're going to do a simple box plot that summarizes for groups of cases. Going to define it. And the variable is X, and the category axis is the sample name. Don't really need to mess with too much else. Okay. And here are our box plots. And so remember our sample 1 was, I should have given that a different name. Now let's go back into our data and go to variable name, our values. Sample 1 isn't going to be sample 1, it's going to be normal. We're going to add another one. Sample 2 is going to be dry eye. Now if I did this in a week, I wouldn't remember which one of those two are normal and dry eye, and I'd have to look up a lot and just get confused. And this way, it self-documents. So we like that. We'll go to graphs, box plots again, and define. It's kind enough to remember everything. You go OK. And now we have normal people on, this was their grade quality, which, by the way, we could have done by labeling that X. I'm going to call it comfort because I don't remember the name of it. But you can put out the whole, and I'm going to give it comfort scale so you can see you can write regular text. Graphs, box plot, define. Okay. Now, this gives it a title, the comfort scale, and so it's important to self-document along the way. The other thing is you don't want to report with a thing that looks like a computer code. You can double-click this graph and go into an editing function, in which case you can click on that and add a space. Same way here. Oh, that's already got the space. Okay, so there we are, a nice graph that shows you things. One thing that, and then it saved it in the original output file as what it looked like after you edited it. In graphs, there's something called Chart Builder, and you need to tell the computer what kind of data you have, and that comes over here in this scale. So our game, it figured out that it was nominal data and that the X was continuous, or it calls it scale. Sometimes it doesn't get that right, and you need to, for example, gender, you wouldn't call it scale. You would want it to be nominal. So you would change those. Even though they're 1 and 2, they're not scale, they're nominal. So you need to do that before you go into the chart builder. And then it lets you do things, and it's a little bit of a learning curve. I think it's just easier sometimes to go into the legacy. But we'll find that sometimes you actually have to go into chart builder to do some types of charts. So that's the box plot and the histogram, and where you go to find the statistics when you're just trying to look up some things, and it's pretty straightforward. And so we've generated this data. So what you want to do is is when you, in your project where you're simulating your study, you go in and will come across more complicated designs than independent samples. It's not a very common thing to do, to have that. It's usually got crossover, repeated measures. Like in this article that I had used, it had 4 treatments that were given to the same person. So in later videos, we'll discuss correlated articles. So that's it.